Banked curves. Banking curves can help keep cars from skidding. In fact, for every banked curve, there is one speed where their entire centripetal force is supplied by the horizontal component of the normal force, and no friction is required. Let's figure out what that speed is for a given angle and radius of curvature. Here's a top view and a front view. We know that the direction of our acceleration is towards the center, so now we have to create axes. So note that these axes will be different than for the inclined plane because the car is not expected to slide down the plane. Instead, it must have a horizontal acceleration to go in a horizontal circle. So we want to line our x-axis up with the acceleration. First, do a free body diagram. So let's assume there is no friction necessary. We know that we have mg down and a normal force that's perpendicular to the plane. And our acceleration is towards the center. Next, decompose the forces that don't align with the axis. That would be Fn. So we need one in the vertical. So this would be Fn cosine theta because it's adjacent to our angle. And this would be our radial direction. And that's Fn sine theta because it is opposite the angle. Now let's solve for the velocity such that no friction is necessary to keep the car on the road while going around a curve of radius r and banking angle theta. Let's do the vertical direction first. Fn cosine theta minus mg equals 0. So Fn cosine theta is equal to mg. So Fn equals mg divided by cosine theta. Now let's do the radial direction. Fn sine theta equals ma. So Fn was equal to mg over cosine theta, and A is equal to v squared over r. Now we can divide both sides by m, cancel them out, and now sine divided by cosine is simply tangent. So we have g tan theta equals v squared over r. So now to find v, we're going to multiply by r and take the square root. So v is equal to the square root of g r tan theta. And here it is again. The velocity necessary to keep the car in a circle without friction is v equals square root of g r tangent theta.